Hi there! In this third video of the hands-on train and deploy real-time ML, we will build our first predictive model. But before using machine learning, we're going to establish a baseline. That is a very simple model that gives us a reference against which we will compare later models and decide if we're actually doing better by adding more complexity. So let's jump onto the code. So here's my project. I open it using Visual Studio Code on my laptop. And here, if you go to the make file, you'll see there's a baseline command that I created, which basically what it does, it runs this source/baseline model.py file. So let me go there before we run it. Here, the main function is called train, which is just a convention because this model has no parameters, as you will see. But what does this function do? First, it pulls in the Comet ML SDK. We want to track every experiment we run. And to do that, we need to use Comet ML, the Python SDK. Here we just load the API key and the workspace name from the environment variables, and we create our experiment. Next thing we do, we split the data. There's something you have to do every time you create machine learning models. You need to split it into train data and test data. Train data is used to fit model parameters. Test data is not used at all during training. It's just used at the very end to check the model performance, to check the test metrics. In this case, we're going to use the mean absolute error. So here is the data split. And then finally, we compute the error. But what's the model we're using? If you go to the get baseline model error function, you will see that our model, our predictions, are just precisely the current value. So the baseline model that we're using here is, if we want to predict the price in 1 hour, we're going to use the current price. This seems like a very dummy baseline, but in problems like this, predicting cryptocurrency prices, which are extremely hard and very stochastic, this is actually a very good baseline. So using the current price as your forecast tends to work really well, which is good and bad. Good for now, but as we will see, it turns out it's really hard to beat the baseline. But in any case, having a baseline lets us compare posterior efforts. So we're going to start adding complexity using machine learning, but the question is, are the models we're creating better or sufficiently better compared to the baseline? So finally, we return this error. Here it is, and then we log it. So we call it test mean absolute error, and this is a metric we're going to log to our Comet ML experiment tracking. So let me run this. I go to the command line and I run make baseline. That's it, it completed. So now I'm going to go to my dashboard in Comet ML for the experiments. I'm going to refresh it, and here it is. Here's the model, the baseline that I just created with a test mean absolute error of 73 point something. Okay, so this is the reference against which we're going to compare models that we're going to develop from the next lecture. See you there.